learn what is the .NET programming language. So the .NET programming language means what is the exact the meaning of the .NET framework and how we can use and how it works. Okay, so generally, as you know, the C# is an object-oriented programming language. Whenever we write any code in a C#, so where it will get a compile and how we'll get the result from the C# code. So that a process, the platform where these things are happen, which is called as a .NET framework. Okay, so whenever you give the C# code to your system, then it will give you the output in your console. So from where that output will came, which is the basically the from the .NET framework. So how it will work and what is the .NET framework. Let's first understand VB6 and C++ program. So non-.NET application. So earlier there was C++ programming was there. So it was not non.NET. So earlier how it was work. So they just explain here. We know that computer only understand the machine level code. Machine level code is called as native or binary code. So when we execute VB6 C++ program, the respective language compiler compiles the respective language source code into the native code, which can then be understood by the underlying operating system and hardware. This process is called as depicting in a image process is depicted in a below. Means what exactly they want to say. Here is the earlier VB6 or C++ programming is there. Then it goes to the non.NET application. So VB6 compiler is there. So earlier what happened, if you are using the VB6, then there is a VB6. If you are using the C++, then there is a C++ compiler. If you are using the Java, then Java compiler. So there are different compilers as per the your language, okay, which is you are using. Okay, so what happened, it converted into the assembly, which is called as a DLL and .exe. We'll see the meaning of the executable files and what is the meaning of the DLL. So native code and machine code. Native code means this is your motherboard, microcontroller, this thing is there. So these things you are writing the code. You are writing the code in a C++. Okay, you are writing your code in a C++ because you know, if I will tell write the code in a binary and hexadecimal 011002 so it will work out. No, you will say how I can write the machine understandable code is really difficult to write. So what they did, they create the compiler. Okay, VB6 compiler there, it will convert it into the machine understandable code, which means that 1100111100 means like this. So this code go into the machine and this machine will return the result to you. Okay, and again this compiler it convert to the human understandable response and it will display you. Okay, this is our operating system where it will goes to the operating system. The code, this code is called as native code or machine code. This code is called as a native, but who convert it? This is the compiler convert the human understandable C++ Java code into the assembly format or native machine code, which is called as assembly. So many times you saw that assembly.dll. What is those things? So those are nothing but the native code and the machine code. That's it. Okay, so we'll go into more detail. Native code is a specific native to the operating system on which it's generated. So this code is specific to the operating system. If you go in a folder Windows assembly, see there is a Windows. So these are the Windows means operating system assemblies are there. You can see there are many assemblies here. Assembly is there. See, if you can see the ASUS assembly, whatever the software you install in this system, so it will add their assemblies in your Windows. Okay, so I go in assembly. You can see here there are different assemblies are there. If I go in any one of their system.data, so you can see the DLL file is there. So DLL is nothing but you can see DLL is nothing but the machine code, so that my machine will understand it. Means I am doing whatever the operation I am doing. How I click here to minimize it. I click here to minimize. So who perform? Operating system is performed. But what input we need to provide the operating system? That is the native code or machine code. So who convert? The compiler. It will convert that. Okay. So for that, and how it will run and where it will run, for that again in advance is that there is a .NET framework. So we'll move into the .NET framework. Native code is specific to the operating system. So each operating system having their different, if you copy this code and try to run in other system operating system, it will not work. Okay. So native code try to run in other operating system, it will fail. So the problem with this style of programming execution is that it is not portable for one platform to the other platform. Means this is not a portable because platform change. Means I mean using the Windows 7, then it will run on the Windows 7 only, not on a Linux. Okay. So let us understand how .NET program execute. Using the .NET, we can create a different type of application. A few of the common type of a .NET application includes web, Windows, console, mobile application. Irrespective of the type of application, when you execute by .NET, application from happen. So as earlier in the first session of our training, I have explained you what is the web application, what is the Windows, console, and mobile application. So these are the different applications we create using the .NET. Okay. So but for that it needs to be converted into the native code and a machine code. So who take care about it? So our .NET framework will take care. If you are writing the JavaScript, who take care? Your browser will take care about it. But in this, whenever you are writing the server side C# code, then you require the .NET framework for that to convert that into the native code, right? Because see, whenever you are writing the things in your browser, it will compile by your browser. Okay. And no need to send it to the machine and convert, because it's in a browser, means the client side. Okay. So whatever the response we required, we send the request to the server and get that response. Okay. So here you are in a .NET. Okay. So the .NET application get compiled into the intermediate language. Intermediate language is referred as a common intermediate language, that is a CIL, Microsoft Intermediate Language, MSIL. Okay. So what it means, it compile into intermediate language. Okay. So common intermediate language. So if see MSIL, it called as MSIL. If I go here, you can see GAC MSIL. So what is this a GAC, which is a global assembly cache? You will understand it as shortly. Just a moment. So here this is a MSIL. Whatever the files, those are here, those are in a MSIL. So intermediate language. So those are converted into the, here the things those are required for your operating system, those are already converted into the DLL assembly format. It means that those are already compiled and ready, so that from here directly it goes to the machine and it will execute, right? So you understand the DLL is already ready. So what is called as Microsoft Intermediate Language? The application generated and see, Microsoft Intermediate Language, both .NET and non-NET application generate assembly. Assembly means native code. Okay. Their extension assembly are two types. Their sorry, really sorry. Sorry. Just a moment, guys. Quickly go. Okay. So here, so assemblies are two types. Okay. So one is the DLL and other is the .exe. DLL and .exe. Okay. You can see here. You can see here DLL and exe. There are two types of assembly. Okay. So here assemblies have an extension .dll or .exe. Exe means executable file. Okay. So for example, if you compile a Windows or console application, you get a .exe. If Windows or console application, then .exe. Whereas when you compile the web or class library project, then it will get the .dll. Means we have the classes, predefine the classes we use. In SPFX we say import Microsoft dot something is there. So those are the predefined classes. so their DLL is already exist. It contained only the classes, methods and all. But if you want to display some output, okay, on console or on Windows, then it's in a exe format. Okay, console means your command window. There are difference between the .NET and non-.NET assemblies, that .NET assemblies is in intermediate language format, whereas non.NET assemblies are native code format. Native code means binary code format. This is, but in a .NET assemblies those are, but nowadays these things are not happening. Okay, so you cannot find this example here, but nowadays .dll and .exe are get converted. Okay, non.NET application can run directly on a top of operating system, whereas .NET application run on the top of a virtual environment called as common language runtime. Common language runtime component called just-in-time compiler, which will convert intermediate language into the native code which underlying operating system can understand. See, now in more detail below diagram you understand what is exactly meaning of the .NET framework. So interviewer asks you the question on a .NET framework. What is the .NET framework? What is the assembly? What is the CLR? What is the intermediate language? What is the native code? Okay, who convert the intermediate language into the native code? What is the just-in-time compiler? These are the questions may ask you if interviewer go into the .NET related things. Okay, so in a .NET application, execution consists two types. Language compiler compiles the source code into the intermediate language. JIT compiler in a CLR converts intermediate language into the native code. Means there are two steps. First, your C# code is here. Your C# code is here. It get converted into the .dll or .exe as assembly. Again, it will get converted into the your native code, like 0110111. Okay, so this thing, so conversion of this to this, and again this to this, there are two steps. DLL is there. If DLL is there, again who convert this? Okay, so these, there are two parts. First thing, see, try to understand that here your language compiler is there. Who is there? Your language compiler is your .NET application is there, your language compiler. So you can say here language compiler. So whatever the language compiler, .NET, C#, .NET, C++, Java, J#, main languages are there. Okay, so here it convert it into the DLL or exe. Okay, your exe is ready, your DLL is ready, it's in your hand. Okay, now who convert this DLL and exe into the binary code or native machine understandable code? Who convert? Then there is the, so see, this is called as intermediate sorry. Okay, so it's called an intermediate language, and who convert this into this is a CLR. What is the name of CLR? There is a common language runtime. Okay, and again in a CLR there is a JIT compiler. Now nobody asks you this about JIT or this thing, but still you know, just in time compiler. Okay, and then it will convert into the DLL and then it will convert into native code. This 011 is machine understandable. So you understand what is the, and overall these things happen under the your .NET. This is our .NET framework. That's it. This is our .NET. You write the code internally, what things are happening you don't know. .NET framework will take care about it. Okay, so just a minute. Okay, so as while working here, so we are installing the .NET framework here. .NET. Why? Because we are writing our code in our Visual Studio Code. That's why .NET compiler will require. Okay, so see here. Now we go in a more detail. See here in the C#, VB, there are n number of languages. Okay, those are get compiled into the .NET. Okay, so in a .NET application, so these are compiled using respective language compiler. Means whatever C#, J#, F#, Java, PHP, whatever. then it will convert it into your intermediate language. Okay, this first step is completed here, conversion of intermediate language. Who convert? The respective language compiler convert. Okay, next step started. Next step is, now how machine will understand that? How machine will understand that? Then who will take care? Common language runtime will convert. See, intermediate language means this is your intermediate language. This is just in time compiler or common language runtime compiler. It convert into the native code and it will goes to the operating system and will get the response from your operating system. Operating system means this is, it will interact with the machine, and machine binary decimal codes understandable, binaries are understandable to the machine, and it will respond to you. Okay, so this is the actual execution of a .NET framework and how this is the .NET framework. So what you need to do, your role is here only. You need to start work, you need to work on one specific language. No need to worry about what happening here, how it will goes here and how you will get the response there. No need to worry, .NET framework will take care for you. Okay, so at the end, these overall things are managed by the .NET framework. Okay, moving ahead. So this is the assemblies are get converted, and you can see those assemblies are in assembly folder of Windows. Even though you create your assembly, deploy that assembly in your system, you can see those assembly here. Any software, anything you install, their specific assembly is there, and it will be available here. If you go in assembly, you can see there are different mini softwares are there. All software related assemblies are here. Here SKP, I don't know language module and all. So, but there are many assemblies are there related to the software which you install. So container, cursor, means these in Windows contain all the Windows, and whatever the assemblies we create, it will available in a assembly folder, which is the GAT folder. Okay, so whenever we deploy any assembly in our GAT, then you will understand. Okay, since .NET assembly is an intermediate language format and not native code, .NET assemblies are portable to any platform. Now you can create that DLL, you can take it to the Linux, you can take it to the Ubuntu operating system or Mac OS. It will execute there also, as long as the target platform of a common language runtime. The target platform CLR convert the intermediate language into the native code that is underlying operating system can understand. So you know that. So whatever the operating system understand, in that format that code will get converted. So intermediate language is also called as managed code. So whatever the code is native code or managed code are same thing. Okay. This is because CLR manage the code that run inside. For example, in a VB6 program, the developer is responsible for deallocating the memory consumed by the object. If the programmer forgot to deallocate the memory, may run into the hard and detect out the memory exception. On other hand, .NET program need not to worry about deallocating. Means you are creating object and you have not disposed that object. Means as I have shown, on a heap memory object, for that specific object memory is get allocated, but you will not dispose that object, remain there, and overloading those objects means your heap memory will get flown out, then exception will occur. But in .NET that thing will not happen. If you close your program, it will automatically dispose those objects and release the memory which one is allocated. Okay, so so also you know that garbage collection in a .NET there is a garbage collector, means whatever the memory allocated on a heap memory and which is not utilized, so it will automatically release that memory. We'll discuss in the later session. Okay, so .NET supports different type of languages, so you understand what is the .NET program is similar to the Java program execution. In Java we have bytecodes and JVM is a virtual machine. No need to worry about it. So this is the exact the process how the .NET framework execute. Okay, so in a more detail, if we go in a more detail, what is the ILDASM and ILASM? Okay, so the process how the assemblies are converted, how the DLL will get converted, so this process is explained here. Okay, So we stop here. So I hope you understand what is the .NET